Hey everyone, welcome to the first video of Lecture 7. And we're sort of rounding out the boot camp now in terms of the content. And so in these final two lectures, we're really going to focus on some slightly different stuff than we talked about in the first six lectures. And the first component of this new stuff is thinking about time preferences and how timing of things affects decision making. Okay, and so there are important structural materials to introduce in terms of thinking about this, because up till now we've sort of been examining everything in a static lens, right? We've just had market graphs and other situations that examine things in a static light, but in reality a lot of decisions are dynamic, right? They take place over different periods, and we need to think about a framework to think about those decisions. Okay, and so I'll start our synchronous discussion with respect to this lecture, actually with a small group discussion about an article about the electric car boom and how that's affected resource extraction in Bolivia. And so that's why you see this first part here. So you can look forward to having what I think is a fun discussion about this article and what it means for intertemporal, right, across period extraction of resources, and what that means for the environment and what it means for different countries' economies and so on. Okay, and so we'll start our synchronous discussion section for this lecture with that. And so what I want to begin this video with is thinking about a concept called discounting, because discounting is going to be very important for analyzing decisions that are made across periods. Okay, and why discounting is important in economics especially is because it allows us to compare the costs and benefits, right, associated with the decisions that occur in these different periods. And this is a big deal, especially in the case of environmental and resource economics, where oftentimes we have to make decisions about, decisions today about something that's going to affect people in the future, right? If you think about climate change, mitigating or adapting to climate change now is going to have impact directly right now. Similarly, if we're thinking about extracting resources from a mine or a well or from a river, we don't need to think about just what we extract right now, right? We need to think about planning our future extractions so that we can think about maximizing profits or whatever our objective function is that we care about. Okay, and so in order to account for these different costs are incurred in different periods, we're going to use a discount rate, and a discount rate is basically a reflection of how the way I start the intuition behind what a discount rate is to think about your own discount rate. So you can ask yourself the question: if I was offered $100 today, how much would I need to be offered to wait a year to accept the money, right? And most, if not all of you, should definitely be answering something that's above 100, right? If I was saying I'll give you $100 now, or some X dollars a year from now, how much more money would you need to wait till you have to get that money in a year, right? And the answer is often above 100, because that reflects our measure of impatience in a behavioral standpoint. But it also actually reflects something that's more economically intuitive, which is the idea that if I got $100 today, I could invest that money or do something with that money that provides me more value in the future, right? It's sort of like thinking about, if I got $100 today and I put it into a bank or into a stock, I'm most likely going to have more than $100 a year from now, because that money, drove value for someone right now who was willing to pay. It's important to understand why a discount rate is meaningful in a behavioral context, right? This measure of impatience, but also just from an economic standpoint, why it makes sense to have money now compared to later, because of the ability to invest that money and allow it to grow. Okay, and so I think the following graph can be helpful in thinking about visualizing what a discount rate means in practice. So I'm going to draw three separate lines, but let me first label the axes here. So my y-axis is going to be dollars, and my x-axis is going to be time. Okay, so time 0 is today. So let's think about time in terms of years, and then we'll have 20 years from now, 40 years from now, 60, 80, and 100. Okay, and let's say I'm willing to give. Let's say you have $100, sort of that I'm willing to give you right now. What's the value, the present value, right? The value today of getting $100 in some X number of years, right? So if I gave you $100 today, right? Obviously, the value of that money today is $100. But let's say I give you $100 in 50 years. What I want to know is how much is that worth in today's terms, okay? And that can tell us a lot about the discount rate. So if I draw, let's say I draw a line like this, and then I'll draw a line, we'll go green and red. Okay, each of these lines represents a different discount rate. Basically, what's the reduction in value of $100 if I gave it to you in some X number of years determined by the X axis, right? And so if my discount rate is, in this case, 2%, okay, this is the trajectory of how much $100 is worth in today's terms if I gave you $100 in that time period. So if I gave you $100 in year 60, for example, 60 years from now, this with a 2% discount rate is how much that $100 would be worth in today's terms, right? So you can see it's a lot less than $100. It's even less than $50, right? And so the idea is that money that we're in now versus money later, right? I'd much rather have that $100 given to me today than in 60 years where I have no idea where I'll be. Who knows? I might not even be around, right? And so that's the behavioral idea. But getting $100 now also allows me to invest that $100 so that in 60 years I have something that's much more than $100, right? And so that's the entire idea behind this. And so each of these lines represents a discount rate that is increasing. So now we go to a 4% discount rate for the green line and a 6% discount rate for the red line. So the higher the discount rate, right, the less valuable, or so the more $100 in X years from now, how much is that worth today? That value is a lot lower the higher my discount rate. Okay, and we'll talk a lot more about how this discount rate applies intuitively and actually using it in some practical calculations. Okay. So before I finish up with this video, I want to do a little bit of discount rate practice. Okay, and so I want to try to go through a couple of these questions, and feel free, of course, to try these on your own before you watch the video. But I'm going to go ahead and try them here. So suppose you have an annual discount rate of 5%, right? Which means that an annualized rate is the rate that we're always going to be using. You can also have like daily rates or monthly rates, but most of the rates that you see in the real world are based on an annualized rate. Like you've seen those things in car commercials, APR. That's the annualized percentage rate that is associated with taking money or credit from a dealership. And so suppose you have an annual discount rate of 5%. How much would you need to be offered a year from now to be indifferent between that amount and $200 today? Okay. So how do we think about solving it? So what it's asking you to solve is, what is given a discount rate of 5%, right? What is the indifference point in terms of getting $200 today and some X dollars a year from now, right? Well, the way you can solve this is if I have $200 today and that $200 grows at a 5% rate, then I'll end up with $210 a year from now, right? And so you'll notice I sort of, the terminology I used was the $200 grows at a rate of 5%. So we'll talk about this in the next video a little bit more, but the discount rate and the interest rate are actually interchangeable in terms of they're the same rate. The interpretation is just different in terms of the intuition, right? An interest rate, which is something that many of you are probably familiar with, is that's how fast my money grows if it's put into a bank account or something, right? A discount rate is how much does the money now sort of decline in terms of how much do we discount it, right? If we're given that money later instead of now, right? And the reason why those two things are sort of interchangeable is because if I'm not given the money now, then I'm foregoing the potential interest I can get on my money. So that's why it's not $200 today is $200, in a year from now in terms of like the bills you're handed, but the value of that money is different because if I'm given $200 today, I can invest it at a 5% rate. If I'm given $200 a year from now, I just get $200, right? So there's sort of this opportunity cost type of argument here. Okay, so how much would I need to be offered a year from now to be indifferent between that amount and $200 today? So based on this discount rate, the answer would be $210 a year from now to be indifferent between that and $200 today. Okay, and that's because my money could have grown at a rate of 5%, which would have left me with $210 a year from now if I had been given $200 today. Okay. The next question says, suppose you are indifferent between $50 today and $60 a year from now. What is your annual discount rate? So in this case, we just use the exact same expression we did in equation 1, but we need to solve instead for the discount rate, right? So we have $50 today, right? 1 plus, I'll call my discount rate delta here, is equal to $60 a year from now. Okay, so we need to solve for delta. So we have 50 plus 50 delta equals 60. So we have 50 delta equal to 10. Divide both sides by 50. So my delta is equal to 0.2. Okay, so my discount rate is 20% in this case, right? So that's a little bit of practice with discount rate and an overview of what it means. In the next video, we're going to talk a little bit about the discount rate and interest rate intuition, as well as some other terminology that'll be important for looking at these problems that we encounter in the future. Okay, see you then.